From the outside, laser welding processes often look identical. A focused laser beam creates a molten pool, and a weld seam is formed. Whether filler wire is used or not, the visible process appears stable and controlled. But the decisive differences do not occur on the surface. They occur inside the weld spot. Within just a few milliseconds, the material is exposed to extreme temperature changes. This is where stability is lost, where stresses build up, and where the foundation for cracks is created. What appears to be a stable process from the outside can, in reality, be thermally unstable inside the weld. Conventional laser welding is a well-established and reliable process. It delivers good results and is successfully used in many industrial applications. But even a well-functioning process has its limits. These limits are defined by how energy is delivered to the material. During a pulse, energy is introduced without precise control over how temperature evolves inside the weld spot. The material heats up rapidly and cools down just as quickly. This leads to unstable molten pools, strong thermal gradients, and the buildup of internal stresses during solidification. These effects are not caused by incorrect process settings. They are inherent to the way conventional pulses deliver energy. Superpulse technology takes the next step in laser welding. It does not rely on increasing power, but on improving how energy is delivered during the pulse. Instead of introducing energy without control, the pulse is precisely shaped over time. This allows the temperature inside the weld spot to be actively controlled. With microsecond-level resolution. As a result, heat input is no longer left to chance. It becomes predictable and controllable. The molten pool remains stable, and the process becomes significantly more consistent. The difference becomes clearly visible in the process itself. With superpulse technology, the molten pool remains calm and stable. There is no turbulence, no boiling, and no uncontrolled material movement. Heat is introduced in a controlled way, and cooling occurs under defined conditions. This reduces internal stresses and prevents crack formation from the beginning. As a result, the process becomes more stable, more predictable, and easier to control. Even materials that are considered difficult to weld can now be processed reliably and reproducibly. By reducing rework, minimizing post-processing, and increasing process stability, superpulse improves productivity and ensures consistent quality. Conventional laser welding continues to be suitable for many standard industrial applications. However, superpulse technology represents the next step in laser welding. It enables precise control over how energy is delivered and how temperature evolves within the weld spot. As a result, the welding process becomes stable, predictable, and reproducible. Microstructure formation is no longer left to chance. It can be controlled. This leads to consistent weld quality, reduced defects, and improved process reliability.